Hello, everyone. Welcome to our monthly town hall. We're going to give folks just a minute to join and get on the line before we get started with Leemon and Mance answering some of your questions today.
I'm looking forward to it. I always enjoy talking to you guys, and I appreciate how many of you join us. It is always a pleasure to have you here. Poland. Hello from Poland. It is good to have you here. Hiya. Austin, Texas. I used to live there. Ontario, Canada. Australia, Honduras. That's cool. St. Pete. Is that the real one or is that the one in Florida? Amsterdam, Brooklyn. I shouldn't say real one. They're all real ones.
My goodness.
Oh, wow.
Coming in.
Pittsburgh. I used to live there too. Czech Republic, Louisville, Kentucky. South Africa, Cape Town, Hong Kong, welcome. Belgium, welcome. London, Turkey, Montreal. Hello from Dallas. I've heard of Dallas. I think I was there once.
I've not heard of Pasadena, Maryland. I've heard of Pasadena, California. So
ooh, interesting.
We learn something new every time. It's great.
One of us is from the whole world, man. I'm with you. Since the day I was born, I have moved on average every 3 years throughout my life.
Is that true, Leemon? I didn't know that.
It is. I have moved quite a bit.
Wow.
Kingston, Jamaica. Oh, I spent a week in Jamaica once. I really loved it. Jamaica is a beautiful place. American in China.
In Sydney, thank you for partying with us at 1 a.m. We appreciate that.
Yes.
All right. We are a couple of minutes past the top of the hour, and we usually wait a little bit longer, but we have so much to get through today. We have had an incredible number of questions from the community. I know we won't be able to get through all of them today, but we are going to do our best to get through as many as we possibly can. I want to first of all say a big thank you to our community. I know we hit a lovely milestone on Twitter last night, 100,000 followers, and that is thanks to you all and everything that you are doing to help raise awareness of the project. So a big thank you there. For those who are joining the town hall for the first time, welcome. We're so glad to have you here. I do want to share a little bit about how we do these because it's probably a little bit different from some other formats and other things that you've seen. So we do send out an email and people can submit questions throughout the course of the month. And then what we try to do is, so for example, this time we had over 250 questions. We know we can't get to that in an hour. We know we can't get to that even in a whole day. So we try to answer the questions that get asked the most frequently, or variants of it that get asked the most frequently. We want to make sure we're addressing those. Mance has previously talked about some of the limitations we have in terms of sharing information that's not yet public. And then the other thing that we always try to do is make sure that questions that can be answered elsewhere, so things that are on the website, that are on the FAQ, that are in our YouTube channel, or even perhaps that were just answered last month or the month before, we try not to repeat those because we know that we have longtime community members on here who are really just hoping to get answers to some of the latest and greatest. So if you feel like you haven't had a question answered, I would encourage you to also look through the FAQs, look through the website, and then this community is a great resource because they do know a lot of that historical information and information that we have shared before. So, things like use cases, things like founders selling, a number of different examples. We've covered many of those in the past. So we always try to bring something new and fresh and make sure that these sessions are informative for you. So with that, I am going to jump right in. This first one is for you, Leemon. Do you see Hashgraph revolutionizing the internet as we know it today, or more so just improving on it?
Oh yeah. So Hashgraph, ledgers in general, are absolutely going to revolutionize things. They're going to become part of every part of the economy and the world society. That doesn't mean they're going to do everything. So there'll be a lot of things that you don't do in a ledger. You don't use a hammer for everything. Hammers are wonderful tools, but you don't do everything with a hammer. Not everything is a nail. So most websites, you wouldn't bother to host on a ledger. There's no point. Maybe there are some rare websites where it makes sense, but in most cases you wouldn't. Most outsourced computation, you go to AWS or you go to GRP or something on the Google Cloud, or you go to Microsoft's Azure, but you wouldn't do it on a ledger for most things, but some things you do, and then it's really important. So ledgers are for wherever you need to have this ultimate trust that it will do the right thing and that everyone in the world will see it and will see the same thing. Ledgers are when you need trust, that I don't have double books where I show you one thing and show him something else. It's where everyone sees the same thing and where we absolutely know that the right thing will happen. Your token will only move if you have signed it. Your smart contract will only do the right thing. The file will be deleted when it's supposed to be deleted and not when it's not. All of those things are what you need. So ledgers are all about trust, and they're trust amplifiers. If you had this very weak form of trust, all you have to do is trust that you won't have a lot of the nodes conspiring to do something bad. You turn that into a 100% guarantee that that transfer really did go through. And so it's a trust amplifier. This is going to affect every little piece of the economy, every type of business, every type of interaction. It will be in part of all of our social media. It will be part of everyday life in many, many ways. Your robotic car will talk to the robotic parking meter and possibly look up information in a ledger to find out for sure that it's sending money to the right parking meter. All of those things. But that doesn't mean it does everything. And we will continue to have an internet underneath us. We'll continue to have web pages. We'll continue to have computation. All those things will continue to be done outside of ledgers, because if you have a bunch of computers do something redundantly, that will inevitably be more expensive than one computer doing it. So if you can afford to have one computer do it, if it doesn't hurt anything, hey, have one computer do it. So different purposes, different tools for different reasons, different tools for different problems.
All right. Thank you, Leemon. Mance, this is a question for you that we actually received earlier on in the month, but I think is very timely given the MTech report that came out yesterday. How big is the possibility that the digital US dollar from the Federal Reserve will be based on the algorithm from Hedera Hashgraph? When the Fed does decide to do something here, how would this affect you? And can you tell us a little bit more about the collaboration with MTech and their new Dawn project?
Yeah. Well, first, let's just talk about what's the value proposition that Hedera brings to CBDCs in general. CBDC, central bank digital currencies, are going to be built and customized for specific monetary authorities. Those are going to be bespoke solutions, very likely. They're going to require unique data privacy and operating conditions. Hedera, with the Hedera Consensus Service, gives those monetary authorities the ability to build customized CBDC networks for their countries, but they can operate those permissioned networks with whatever parties they want to operate the nodes. It's a permissioned, basically application network run by parties of their choosing. They can protect user privacy, but at the same time leverage a global ordering service for their consensus process and for enabling interoperability between those CBDC networks using this global ordering system, which is HCS, Hedera Consensus Service. So MTech has a vision to create a digital cash infrastructure. It's a great vision, it's a bold vision. Their idea of reimagining cash with central banks as they consider using distributed ledger technology, DLT, is to close some of the economic gaps in developed and emerging markets. It's an important use case. It's one that we believe in strongly. But to be more specific, MTech builds solutions specifically designed for fintechs and central banks. They've built a regulatory sandbox for fintechs that want to go to market and want access to central banks and markets across Africa and the Caribbean. This sandbox provides central banks the opportunity to collaborate with fintechs in those respective jurisdictions and encourages innovation in those markets. MTech will be integrating with HTS, the Hedera Token Service, and HCS, Hedera Consensus Service, in their regulatory sandbox. We continue to work through different potential paths with MTech around CBDC and that and MTech's made a significant amount of progress in a very short amount of time. What they're doing, Carmel Cadet is doing and leading that organization is exceptional work, and we're just proud to be working with them.
Thank you, Mance. Leemon, the next one's kind of fun just because of the word. Has Hedera solved the blockchain trilemma like Definity or Algorand or other networks claim to have done?
Oh, sure. So in the sense we have as well. So what this is that you want your network to be fast and secure and decentralized, all three. We absolutely have this, and we do all three. And other people have also said, hey, we do all three. Look, we've solved the trilemma. So in that sense, we've solved the trilemma. Language evolves over time. By the original definition of the word trilemma, nobody can solve it. But by the way it's being used now, yes, we have solved it. Now, what do I mean by the original definition? Well, the original definition wasn't saying you can't have all three being pretty good. It was just saying there's a trade-off. If you want to make two of them really good, the third one will become worse. Now, maybe you've made all three good, but it's still a trade-off. You can still make two of them even better at the cost of making one worse. So yes, we've solved the trilemma. Other ledgers have solved the trilemma in the sense that everything is good. But the trilemma is still there in the sense that there's still a trade-off. And in fact, in computer science in general, there's always, for example, a time-space trade-off. Almost every problem has a time-space trade-off. You can be fast, or you could use just a little bit of memory, very small amount of memory, and it's a trade-off. If I'm willing to use more memory, then I can make it faster. So I should do it this way. The memory is worse. I'm having to use lots of memory, but I can make it fast, which is good. Or if I'm willing to go really slowly, then I can save lots of memory. And so I'm saving lots of memory, and that's good. It's always a trade-off. Now, of course, sometimes you'll find a new algorithm that makes them both get better. Yay! But you still have the trade-off. It's just a trade-off now at a higher level. They're both better, but there's still a trade-off. So that's how the trilemma works. And yes, we have that.
All right. Thank you, Leemon. Okay, Mance, how do you correctly spell, capitalize, use HBAR?
Yeah, so you use it in the same way you would use USD or dollars when writing. If you are writing a sentence and you say USD, USD is normally all caps. In the same context, HBAR would be all caps, capital HBAR, all caps. If you write out the word dollar, it's almost always lowercase. HBAR, same thing, HBAR, lowercase. So dollars equals HBARs, lowercase. If you're using the symbol for dollar in that same type of context, you would use the HBAR symbol with the lowercase, and it's a little HBAR with a line through it. I think, Zenobia, if we can, it would be good to
Yep, we've got it posted in the chat too.
Excellent. There you go. All right.
So hopefully Mance's explanation is helpful, and then the actual language we've shared in the chat right there. Leemon, last time you mentioned that the council has power to, for example, delete a file from the file service. As the network becomes more utilized, this kind of service may be required more often. How will the council delegate these tasks? Will you have a trust and safety team?
Oh, we have a trust and safety team. So we have multiple. Let me tell you what we do. So we have an information security department, a team that is involved in information security, making sure that we are keeping things secure, doing things in a secure way as much as possible. We also have a compliance officer responsible for making sure that we're following all the best practices and complying with all the regulation type things and doing everything the best way. And then we have our technical steering and product committee. This is a committee of the council made up of council members, and it has a subcommittee on cybersecurity. And it's all about looking at our procedures and our processes and our equipment and anything we can around security. And we discuss it a lot in the major meeting too, in the TechCom meeting, as well as within the subcommittee. And so we have the council is involved, the Hedera staff are involved. We have full-time people for these things, the information security department, and we have the compliance officer. This is incredibly important. In fact, going back to my last comment, 2 comments ago, secure or trust is what it's all about. And so that's why we take security so seriously, because trust is the whole point. So that's what we're doing.
Right. Thanks, Leemon. And then, following up to that, while we're talking about the roles of some of these folks, in a hypothetical scenario, if a governing council member chose to leave immediately before the end of their term, what would happen to the node that they operated, and would there be any penalties for them leaving?
Oh, there's no penalty, and their node is removed from the network, and it's removed from the address book. So we have 20 nodes. If they we need more than 2/3 of the 20 to be up. If someone left, then we would have 19 nodes, and we would need more than 2/3 of the 19 to be up. So we would shrink. The total would go from 20 to 19, and we would remove them. There's no penalty. They're free to go, and they're not locked into jail. But I don't think anyone's thinking of leaving right now, because they all seem to be pretty excited about it, and lots of them are building really cool things on top of us right now.
That's right. Thank you, Leemon. All right, Mance, this next one is for you, longtime friend, ongoing Twitterer. Given the recent departure of long-term employee and decentralized ID expert Paul Madsen, can you update the community on the progress of various DID, distributed identity projects within the Hedera ecosystem?
Yeah, well, so just a word about Paul. Most people may not know this, but Paul and I actually worked together prior to Hedera. Paul and I were colleagues at Ping Identity, where I got to know him very well, and working in this office of the CTO. So Paul has retired. He's moved on. You wouldn't know that by looking at his Twitter feed. He looks like he's not adapting to retirement very well. But we were very fortunate to have Paul with us, and we wish him well. We knew that it was going to come, right? We knew the time would come. Tim McHale has taken the lead on DID related projects in anticipation of Paul's departure. Of course, digital identity is emerging as a central requirement for a lot of different types of use cases through DeFi and CBDC, sustainability use cases, education, healthcare, and others. Ongoing work today with council members includes work with FPOS and the Coupon Bureau and Wipro. There are engagements with companies specializing in digital identity, such as Miko, who recently was nominated for a Finney Award in Australia. Congrats to them, Miko. There are other projects in the financial and banking sector that have far-reaching impact that we are working with, and also other important sustainability projects, specifically addressing device identity and carbon credits. So there's a lot going on that, maybe most of which we're just not able to address publicly yet.
All right. Thanks, Mance. Paul, I hope you are listening. I suspect we will hear about it later on Twitter. Leemon, I'm not sure how small a micropayment this person wants to make, but how will micropayments work on the Hedera system if they are smaller than the transaction cost? Won't this counteract the point of micropayments?
That's why we have low transaction costs. No, seriously, if the transaction costs are $1 or $10 or whatever, then you can't do anything you would call a micro transaction, because I'm not going to pay 5 cents online if it takes me $10 to pay the fee for it. That's why our fee is 1/100th of a cent. It's a 10,000th of a US dollar. And it's even pegged to the dollar so that as our coin price goes up and down, the price stays constant. You can make plans on it. And so that's why it's 1/100th of a cent for it. So if you wanted to pay even a whole penny for something or half a penny for something, then still the transaction fee is a small fraction of it, which is great. If you wanted to go even lower, you can do something like aggregating. So for example, we have electricity markets that people are working on for us, so that when you have, say, a solar panel or a windmill or something producing electricity, you can sell it back to the grid. And when you buy electricity from the grid, you can be buying it from other people. You set up an electricity market to help us with renewables. If you're doing that, you need to pay for electricity. Well, electricity is constantly flowing in. You don't pay per electron that comes into your house. There's too many zeros. What you do is you could pay per kilowatt hour, like 6 cents or whatever it is, or you could pay per kilowatt minute, which is a 60th of that, and it would still work. What you don't want to do is pay per kilowatt nanosecond, but you don't really need to pay per kilowatt nanosecond. Just charge per minute, once a minute or once a second. There's no need to charge per nanosecond. And then the fee is great. So I think it is great for micropayments. For anything that's down to a penny or even less than a penny is fine. And if you wanted to go to a millionth of a penny, just batch them up, or charge for electricity over more than a nanosecond. That's all.
All right, thank you, Leemon. Mance, can you please show us a picture of an active node? I am very curious to see what a node operator infrastructure will look like.
Yeah, no problem. I know people have wondered about this. What does it look like if you were to look at a node physically? Let me share my screen. That's it. That's what a node looks like. Now, actually, it probably looks something sort of like this. It's just a computer that goes in a rack that is stacked full of computers that look like this in a data center somewhere. But that is what a node physically looks like.
Equally.
I like your first node better. What is it?
Oh, that's the drone. That's the Martian drone that NASA put up there.
All right.
Maybe someday we'll have a node on Mars. That'd be great.
It's good for us to all have goals for ourselves and for Hedera. Okay, Leemon, this is a follow-up to last month as well. Can you further elaborate? What are some of the limitations of Hedera nodes, including self-imposed limits, such as throttling, or other natural limitations that might affect users and applications?
Okay, so we have a throttle. We throttle ourselves down to 10,000 TPS. We'll raise that in the future, but we're so far away from usage being there now, it's not an urgent thing. And then the way that works is that the TPS, the transactions per second, are split among all the nodes. So with 20 nodes, each of them gets a 20th of that allocation. And then every second, you could go to one node and send in transactions that are a 20th of that. If you wanted to send more than a 20th of that per second, which would be great, that'd be what, 500 a second? If you need to do more than 500 a second, don't send them all to the same node. In fact, just in general, don't send them all to the same node. What you should be doing is every transaction you should send to a random node. And it just spreads uniformly over all the nodes. Everyone should do that, and then it works fine. If there were a bunch of people that all went to one node, then they would find themselves being slowed down, which doesn't make sense. Everybody else would run fast, but the people that are doing it the wrong way would run slower. So don't do it the wrong way. Just spread out your things to all the nodes. Every time you do a transaction, do it to a random node. If that node is down, pick a different random node. And with the SDK that we have, that's really easy. The SDK makes it easy to automate that so that you are going to random nodes. And if a node fails, you go to a different random node. This is easy to do with the SDK that we have. I think that we internally are managing the SDKs and ensuring that they work in Java and JavaScript and Go. And then there's a bunch of external SDKs that other people are managing that are doing even other languages. So I would encourage anyone who's doing this to do it correctly, which is that. Another thing that might slow you down is if you submitted a transaction and then you waited to get a reply to make sure that it's working, and then you submitted another transaction and then you waited for a reply. Of course, by serializing yourself that way, you're going to slow yourself down. You'd go a lot faster if you just submitted a bunch of transactions and then found out whether they worked or not. So you can architect it any way you want. And since we even have finality in just a few seconds, if you're only just doing a single transaction, just wait for finality and then report to the user that it worked. But if you really do need to do a whole bunch of transactions, you'd want to do it faster than that. And you'd probably want to send them to different nodes that are chosen at random. So you have a choice, but I would strongly encourage people to do this. And I'll just point out, if you were to hard code your software to only talk to one computer on the ledger, it doesn't matter what ledger you're dealing with. If it's Hedera or Bitcoin or Ethereum or anybody, if your entire system is hard coded to only talk to one computer, then if whoever runs that computer turns it off, you're out of luck. You would lose connection to the entire network. So don't do that. Don't talk to just one computer. Use the SDK and make it randomly go to all the computers. There's no need to limit yourself. And then that will work with any ledger. Any ledger will work as long as you're going to random computers, as long as some of the computers are still running.
Very good point, Leemon. Thank you. And we have included a link in the chat as well to some previous testing from one of the applications running on the Hedera network. Mance, I thought this next one was interesting. I don't think we've ever had this question about the council. Hedera has made it clear that governing council members can serve for 2 consecutive 3-year terms. However, after that, after a period of time away, are they allowed to rejoin the council?
Yeah, well, let me set some context. When creating the council, the intent was to create the most decentralized, diversified governing body of any of the public ledgers. And we did that in 3 separate ways. One, when choosing council members, we're choosing across a diversity of industries. They're not a bunch of banks or just tech giants. You know, it's from all the industries across, representative of the entire market. We're choosing council members from around the world, not a single geography. And we choose council members in such a way, council members are limited in such a way so that we have diversity through time. And as the question implies or points out, council members can come in and stay council members for up to 2 3-year terms for a total of 6 years. And then they have to leave. That doesn't mean they can't be associated with the project. It means that they can't be a governing council member any longer. Can they come back? Yes, they hypothetically could come back. But the important point there is that there's a gap in time. There's some amount of time from when they left. They have to be gone for some amount of time before they could be invited back to participate again. So yeah, it's possible for existing council members to serve more than 2-year terms, but under those constraints.
Thanks, Mance. Leemon, I thought this next question was really interesting. Given all of the discussions around CBDCs and awareness of them, if there were a CBDC that ran on the Hedera network, would it run via HBARs? If so, how?
Oh, sure. So there's lots of ways of doing things. You could do a CBDC on a private network that then bridges to Hedera. But if you wanted to do it on Hedera, then you have a choice. You could do it using the token service or the consensus service. Either way, and we have people doing both, building things on the token service and building things on the consensus service. That works both ways. If you do it on the token service, and that means that the token is actually managed by the bottom layer of the Hedera stack. Hedera itself is managing this token. You have the keys to do it. You can mint and burn, or you can not mint and burn. You can set it up any way you want, and you would do that. If you do it on the consensus service, you would stand up an AppNet with a bunch of computers that you run. This might be preferable for a CBDC. I should define it. CBDC is a central bank digital currency. So if a government wants their money to be a token, or some of their money to be a token, that's a CBDC. So I think a government might very well want to do that, have an AppNet. So they run a bunch of computers of their own, but we're using Hedera for the consensus to give you the ultimate trust that it is being done correctly and it's being recorded and it's immutable or controlled mutability. You know, what you want is what you get. And you would do this on the AppNet. And so you would do that. And the way the AppNet works is they're all doing their own, talking to each other and coming to consensus. You could even have privacy if you want. You can do anything you want. And then you have the transactions are going through Hedera to put them in order and put timestamps on them. And you can encrypt them so Hedera can't see them and the world can't see them, or you can unencrypt them, not encrypt them so the whole world sees them and has a permanent record of them. Either way, you can do it either way. You can keep it private or you can have it transparent, either way. If you do either of these approaches, HTS or HCS, token service or consensus service, in the token service, every time you transfer a token, you would do that as a transaction, which you pay for with HBARs. In the consensus service, every time you transfer a token, you do that by sending a message through the consensus service, which you pay for with tokens. And the prices are extremely low, as I said, 1/100 of a penny. But that's what you would end up doing. So you can do it either way, and there are lots of different ways. The HBAR would not be the currency of a company, of a country. It would just be the fuel that runs the engine that's handling it. It would be the grease on the wheels to keep them turning. That's all.
All right. Thank you, Leemon. Mance, next one is for you. Does Hedera have insider trading prevention policies in place?
Yes, absolutely. So first off, Hedera is committed to conducting our business legally, ethically, with integrity, and we've provided guidelines to its employees and other personnel to avoid benefiting from their access to non-public information and to uphold the integrity of Hedera. Wherever possible, we're as transparent as possible with the public and look to minimize the amount of non-public information that Hedera staff holds or possesses. In the event employees do have that type of information, there are guidelines that are formalized and in place to prohibit the staff from buying or selling under our market integrity policy, with the exceptions that are granted for non-discretionary programs, meaning that if a staff member has set up a program for selling tokens, for example, that they have no discretion over, then there are exceptions for that sort of thing. But yes, there are formalized policies in place.
Thanks, Mance. Leemon, the next one feels like a bit of a layup, but I'm going to ask it anyway. Can blockchain ever be as good as Hashgraph, or are we just waiting for everyone else to figure out that the answer is no?
Hashgraph seems to be about as good as you can get. It's extremely secure and fast and has state proofs. And so it looks like it's kind of as good as mathematics will allow. It's ABFT, which is the highest level of security, and it really is ABFT. It's extremely fast. You're seeing huge TPS right now, and that will be increasing in the future. Very fast time to finality. And it does have finality, which is incredibly important. And then it has these state proofs. Anybody can run a mirror node, and you can know 100% for sure that the data you're getting is absolutely correct. And it's guaranteed. Even if you don't store the history, you still can be guaranteed because you have the state proofs. And then you could say, well, what else could you do beyond that? Well, that's about as fast as as good as you'll ever get in a single shard. So the only thing beyond that would be to go to sharding, where you have sort of lots of little networks that all talk to each other. But in order to do that, you have to be able to bridge between these little networks. And to do that, and also be ABFT, and also be extremely fast, you need state proofs for that too. So the Hedera state proofs also make the sharding ideal. And so it is incredibly important that you be ABFT, be extremely fast in throughput and latency, and that you have the state proofs which allow you then to do sharding extremely well too. And so we have all of those. Now I do see lots of ways we can tune the software so that it can be even faster, and we will be doing that. And eventually we'll implement sharding when we need it. Don't really need it today, but certainly we will eventually. TPS usage is growing exponentially, and eventually we'll need sharding, and we'll do that. But it looks to me like it's Hashgraph is basically the right way to go. And you didn't ask about Hedera, but the Hedera governance is also, I think, a key point. You need real decentralized governance, meaning people around the world that you are not just anonymous, but you know who they are, and they are people you would trust, and they act as checks and balances on each other, and they're in different continents, under different governments, controlled in different markets. They're large enough that it'd be hard to bribe them. The governance is really important, but you didn't ask about that. You asked about Hashgraph, and the governance is part of Hedera, but Hashgraph is a layer below that. But that's it.
Thanks, Leemon, for both of those. Mance, the new, or maybe not that new, trend in digital assets is NFTs and DeFi. Can HBAR users participate in some way in each of these in the near future?
Yeah, well, so there are plenty of ways to use NFTs on Hedera today. Suku, for example, has an NFT marketplace that companies can white label from Suku. GoMint was the winner of the Social Good Challenge in our recent hackathon, and they've recently launched on the mainnet with NFTs provided by different artists and community members. The Breakouts has an NFT marketplace that they provide to different artists and musicians. Most recently, they announced Money Mark, who is the keyboardist from the Beastie Boys, selected them and Hedera because of the low carbon footprint and energy consumption that we have in the network. Galaxy is the creators galaxy from Spencer Dinwiddie of the Brooklyn Nets, and Galaxy will provide a marketplace. Next month, we will have a decentralized charity auction on Hedera of Leemon's coins. You've heard Leemon talk about this in the past. There are a couple of physical coins that were created And sometime earlier this spring, we decided let's auction those for charity, for a charitable cause here in Dallas. That's going to happen next month. There may be other NFTs that are part of that auction that's still being worked out. The application that's being used, the auction code base that's being created is going to be made available to the community after we use it. So you can take that and use it for any means that you might find interesting.
Thanks, Mance. So much fun stuff, and hopefully the community is excited for those ways to participate. And I will say we keep hearing about new ways every day. So please, as you hear about them, share them with us. They're coming at us fast and furious, and we love it. Leemon, Hashgraph consensus is open review to protect the network from forking while allowing for verification, but Hedera's network services are open source. Can you explain which of those services are open source, and does that create a risk of forking for those services?
Which services are open source? All of them and more. So yes, Hedera has the consensus service and the token service and the file service and the smart contract service, and there's HBARs, cryptocurrency itself. Each of those, of course, is open source, but also the glue that holds them all together. So when you submit a transaction, the code that parses your transaction and figures out what it means and understands it, that is part of this open source services layer. The whole layer is open source. The part that checks the signatures on it in the background and in parallel, that is open source. The part that does the hashing anyway, there's a bunch of things that go on what the services have to do. The services are all open source. Throttling, that's what I was trying to remember. The throttling that happens at the node is open source. The gRPC connection where people can call in and submit their transaction, that's open source. This whole layer of services is open source. And then we have lots of other tools too that we've just open sourced. And we're always doing demos, and we'll have an auction soon and we'll open source that software. We're always open sourcing that. But for the services layer, everything is open source. The only thing that isn't open source is actually the consensus algorithm at the very bottom. Could you fork it? Sure, you could use these services somewhere else. And it's open source. You can do whatever you want with it. It's Apache too. And so that's fine. That's not a problem. But you wouldn't be forking the network because the state of the network is still, you need more than just services for it to be manipulating it and accessing it. And so you could create a new network that used our services, but it wouldn't be a fork of Hedera. And any mirror node that is talking to us would never be fooled into talking to this other ledger because we have state proofs. There's no way to fool it. You always know who you're talking to. And so in that sense, we still can't fork. But sure, you can fork the services code. That's fine. And you can take our example software and fork it. I mean, that's kind of what example software is for. That's fine.
Thanks, Leemon. Mance, is Hedera a layer 0 solution?
Good question. So when we think about layer 1 protocols, really, they do two functions primarily. They take transactions, they put them into a consensus order, and then that stream of ordered transactions flows through often maybe a smart contract layer, some kind of business logic layer that sits on top. The two are normally in one platform. Those two layers, if you think of them that way, are normally in a single platform. And that's normally talked about as being a layer 1 platform. Now, what we have is the consensus service, the Hedera consensus service, which exposes that bottom layer, just transaction ordering, and that's it. So anybody can write an application or a dApp and submit blobs of information to the Hedera consensus service. You can have many thousands of clients out there running the software, each creating transactions that get submitted to the network. And those transactions using HCS get ordered. And that's all that happens in the Hedera consensus service. It takes all this information, these packets, and puts them into consensus order and then creates a stream out. So if you wanted to think about the consensus being exposed in that way as layer 0, which is frankly the way I think about it, then yes, we are a layer 0 solution because we provide Hashgraph as a service. We also have, as Leemon just talked about at some length, the services layer. And there's, a range of services there that can be used by developers to access, the function of the services in addition. So we have layer 0 and layer 1 services in that context. And then finally, when you're building an app net, or you're building a distributed application that might run in an application network, that's what we call it. It's sort of an analog to a layer 2 solution. That app net uses layer 0, the Hedera Consensus Service. And so we enable that functionality with what we have. So those are the 3 layers as I see them. And we directly provide layer 0, layer 1, and enable the app nets and the framework plugins for frameworks like Hyperledger and Corda. They can take advantage of layer 0. You might think of them as filling that app net or sort of a layer 2 function.
Thanks, Mance. Just like a cake, more layers, more delicious. Okay, Leemon, is it possible to build a deflationary type token similar to SafeMoon using HTS and or HCS?
Yes. So can you do deflationary tokens in HTS, our token service, and our consensus service? Yes. In our token service, there is a burn transaction. You can remove tokens from the supply. You can make the total money supply of tokens shrink. Now, when you create a token, you can decide whether or not to have a key that will allow it to shrink. If you want to, you can create a token that's guaranteed to never mint or burn. But if you want to, you can create a token that does have the ability to mint or burn under certain circumstances. So HTS does allow deflation. Our token service does allow it. Can our consensus service do it? Well, yeah, it can do anything. You have the complete power of whatever language you decide to program in. You don't even have to use a specific language on the consensus service. So if you create a token on the consensus service, you can make it do absolutely anything you want, written in absolutely any language you want. It's up to you. And you just use Hedera to do the consensus and to put timestamps and to put your transactions in order. And so, sure, you can do anything on the consensus service. And if you want to use the token service, you can even do deflationary there, or you can do guaranteed not deflationary, either way.
Thanks, Leemon. Here's another fun one. Why does Hedera not offer a non-Turing complete smart contract service to build dApps that can run at near consensus speed, as opposed to Solidity contracts that are currently capped in speed?
We do. That's what the consensus service does. And I know what you're talking about, putting it on the ledger, but the consensus service allows you to do extreme speed because the processing is being done on the AppNet. It's a way of parallelizing the processing. And so you're certainly not limited. And you could do a full Turing complete program on your AppNet and still run incredibly fast because of this parallelization. The main net isn't having to do the computations. Or if you want an even greater speed, you might even go to a non-Turing complete. By the way, Turing complete just means that your language can do anything. Most computer languages allow you to do anything, and you pay some price for that generality. And when you're more specific and can only do limited things, then sometimes you can make it faster. So we do have that, and we may in the future add even further services to make even more things happen at the native layer in Hedera itself. But the nice thing is that you can make things happen at the native layer right now on an AppNet using the consensus service, which is why we've created that service.
Thanks, Leemon. Mance, in the past, we have shared some of the criteria for becoming a governing council member, but do you envision a way of having not-for-profits participate in the council, even though they don't maybe necessarily fulfill the business model?
Simple answer, yes. In fact, we want some not-for-profits or NGOs or that category more generally on the council. We have worked internally on a set of criteria for what that might look like just for that category. And so we're more than open to that. We're actually pursuing it, and we'll see what happens. But yes, we welcome that. We want that to happen.
Great, thanks, Mance. Leemon, we've had a few questions around interoperability. Can you elaborate on Hedera's vision of interoperability with other blockchains, specifically with other DLTs and entities within the financial services sector? And will Hedera continue to rely on its current EVM integration, or can you share other ideas?
Okay, so we have a huge focus on interoperability with other ledgers. There are a number of projects that deal with bridges, validator networks for the bridge, people that will be able to validate that information is going back and forth between ledgers. I think LimeChain has a project that I think, Zenobia, you can probably put the URL into the chat. I think that would be of interest to people. But that's just one of many projects for bridges. We consider this incredibly important. Our vision for the future is that ledgers are going to need to be able to talk to each other. The most urgent, most immediate thing is that you imagine a token on one ledger becomes a wrapped token on another. That's an obvious thing. Also, anywhere you're using oracles to learn about the real world, you could be using the equivalent to be learning about something that happens on another ledger. And then beyond that, there's a whole host of different uses for having ledgers interoperate. So it is important to be able to do this, and it's a major feature. There's a bunch of projects going on that we're doing work to make them easier to do and to push them along. And then there's a lot going on in the community, and hopefully Zenobia actually put that in the chat. I'm not actually looking at the chat right now, but she's smiling, so I'll assume that's true.
Okay.
Okay. So yes, all of that is important. As for flexibility, as I said, HCS is great for flexibility, and we might even add, or we keep adding new services that give even more forms of flexibility.
Thanks, Leemon. All right, Mance, can you expand on Hedera's involvement in the InterWork Alliance?
Yeah, well, so we were a founding member of IWA. We've worked alongside the other members to support the creation of industry standards for tokenization. To be specific, we've been working on the sustainability working group with a focus on standardizing mechanisms for issuing renewable energy credits and other sustainability related tokens. The IWA's work is going to be critical to building out sustainability ecosystems going forward to further high quality carbon credits, for example. So we also leveraged the token taxonomy framework from IWA to help drive the requirements for the Hedera token service when we were doing design of HTS and ultimately implemented that. So we've been deeply involved with the IWA.
Thanks, Mance. Leemon, is there any way to store data on Hedera and make sure it is not tampered with?
Yes, this is one of the most common uses right now of Hedera. So the consensus service I talked about allows you to set up an app net where you run your own network and you do your own processing. You can have privacy or transparency, and you just send your transactions through the consensus service. That's one of the two main ways of using the consensus service. The other way of using it is you don't have an app net, you don't run any of their computers, you just send messages through one of the topics in the consensus service. And that's it. You don't even do anything with the messages after you've sent them. But because you sent them through the consensus service, they are then recorded immutably on all of the mirror nodes forever with cryptographic proofs that the network as a whole supported it or believed it, had it as their consensus, that it truly did go through the system with a timestamp that is cryptographically provable, with signatures from all the nodes on the network. And it can be shown to a third party, and you can prove to a third party, I sent this message at this exact time, the network saw it and approved it at this time, and here's the digital signatures from the network proving it. You have that proof that you've done it as an immutable permanent record. And we have lots of people using this. AdStacks uses this to eliminate or reduce fraud in the advertising industry. And Coupon Bureau is using this for coupons. You spend a coupon at the store and trying to reduce fraud there. It's an enormous amount of fraud, and they are doing a fantastic thing to reduce that. Everywhere is using this for medical things with vaccinations. And there's Hala Systems using this. There's just a million different companies. Project Starling does this for news and for recording things about the Holocaust in an immutable way that will have a permanent record. I mentioned Hala Systems. They go into war zones and help people to prepare, tell them when there's about to be something bad happen. Just all across the use. Acor Systems is used in healthcare. These are all about storing things immutably, provably, you can prove to a third party that it's valid. You can store data in a way that cannot be tampered with. You can also use the file system, and some people use that as well for different types of storage. So lots of ways of doing that.
Thanks, Leemon. And I will add, for anyone who's not already following our CMO, Christian Hasker, on Twitter, he is posting a use case a day. There's some great stories there. You know, my performance review is not at all dependent on you following him, but he tells some great stories of the applications that are running on the network. The next question I'm going to take, how does news such as new council members joining the council get released? And does Hedera send news to media outlets with an embargo? And I will say, first of all, yes, we use all of the tools at our disposal. You know, we want to always make sure that the message matches the medium. So certainly certain things go out on social media, certain things go out through a press release, certain things go out through our blog. But specifically addressing the issue of embargoes and how we work with media, we do work with media just like, you know, a number of other companies do, including public companies. And we do share information with journalists under embargo. This is not just a, hey, I'm going to send it to you and fingers crossed that you keep the embargo. There is an agreement in place and there are processes in place to say, yes, you have to agree to an embargo, which is part of a journalistic standard and code of ethics. And I think what you're seeing is this industry is maturing in terms of the media in the space. These publications are well run. They are run like a, you know, a traditional media organization. They have codes of ethics that are posted and that all of their team has to sign on to. And so we'll also post in the chat one of those examples. This is the one from CoinDesk, and it, you know, highlights that information obtained by employees of CoinDesk during the course of their duties will not be misused for financial gain. So obviously you are always trying to make sure that you're working with reputable publications and people who will honor that journalistic tradition of the embargo. All right, I know we have less than 10 minutes left. Let's see how many we can speed through here. Mance, any plans for building a bridge to the graph? Though Hedera is not focused on smart contracts, a large portion of the DLT ecosystem is. Yeah,
so very quickly, love the idea. I encourage somebody in the community to write an HIP, a Hedera Improvement Proposal, for considerations of these kinds of integrations. Zenobia, if you can drop the link there to the Hedera Improvements Proposals discussions part of the GitHub, that would be great. Someone, please go write an HIP.
All right. Thanks, Mance. Another one for you here, and I love this. This shows how far and wide-reaching our community is. This person asks, my country, Saudi Arabia, has a 2030 vision to develop the country in all sectors, and they think Hedera is a great technology and would help a lot with that vision. Do you have any plans to have a company from Saudi Arabia as a governing council member?
We would love that. Yes. I mean, we're always looking for potential council members around the globe, Saudi Arabia, certainly. We do have the Zain Group from Kuwait, you know, Middle Eastern, but we could use more representation and would welcome that.
Great. Thanks. And then Mance, continuing on with the council, you have previously said, have you said this, that the 39 governing council members could be filled by end of this year. With 20 seats still to be filled, is this guidance still valid? And can you give us some color on the process for filling council seats?
Yeah, well, so I'm going to stay away from making any predictions. You know, I think that's probably not a good idea, just generally speaking. But what I can say is that the work that's being done is productive. There's a strong pipeline. I'm as optimistic today about the work that's being done on recruiting council members as I've ever been. And I think I'll just leave it at that. I don't think I should go any further than that.
All right, sounds good. Leemon, I think a lot of folks in the community have been wondering this one. We have previously heard about the origin of Mance's name. Can you share any origin story about your name?
Oh, sure. So Leemon is a surname in England going back to, I think, the 12th century or 13th century. It's a traditional name there. And it's a common name. You know, you've heard of Leemon Brothers. Now, there's lots of different spellings of it. Mine is a less common spelling. And clearly, Leemon Brothers wouldn't have had any problems if they just spelled their name right. That's obviously why they had problems. But there's a bunch. At one point, I was able to check, and there were something like 70 people in the United States alive right now that have Leemon spelled my way as their name, which is kind of cool, as their first name. It's more common as a last name, but as a first name. And I have a bunch of relatives that have that. And I once got an email from some random person who said, "Hi, I'm a college student, and my roommate's first name is Leemon, spelled the way you spell it." I just thought that was kind of cool. But yeah, Leemon, L-E-E-M-O-N. It's an unusual way of spelling it, but I enjoy it.
Thank you, Leemon. All right, Mance, we get this question a lot. Due to the major partnerships of Hedera, and I think probably the council members, is it a centralized cryptocurrency or a decentralized cryptocurrency or a hybrid, or can you please help explain the nature?
Yeah, we only have a few minutes, but I'm glad to have this question. You should think about decentralization really along two dimensions or on two axes. One is governance, the other one is consensus. When we talk about governance, we're talking about decisions that are being made about the project as a whole, product roadmap, legal and regulatory posture, use of treasury, those sorts of things. When thinking about governance models, you really have three choices, major choices. You can have a dictator, one company or person making all the decisions. Bad idea because subject to corruption, you know, all the reasons we want to decentralize. Or you can have full democracy. That's the other extreme. But if you have really complex decisions, full democracy doesn't really work well. If the decisions to be made are simple, great, let everybody vote. But if they're complex, like what we just talked about, roadmap, legal and regulatory posture, et cetera, you don't want full democracy. You want something like a representative democracy. And that's where we sit. The council was specifically designed to be the most decentralized of its nature, of any of the public platforms. We don't use governance tokens or anything like that. You know, the problem with governance tokens is that it's possible for a small group of entities to buy up and control governance. Each council member gets one vote. And because of that, we keep governance decentralized. And the decisions are being made by experts around the world, across industries and through time, as we've talked about. So that's governance. Consensus is when you have a bunch of nodes that are all voting on the order of transactions. And so today, consensus for us is each one of those council members running a node, and they have you know, their pro rata weight of the stake that they vote on the order of transactions will be moving to community nodes in addition. They will also participate in consensus. And then finally, we will ultimately get to allowing anonymous nodes as well. Now, one thing to keep in mind, if you look at some of the public ledgers out there today, you can have one or two or a handful of entities controlling consensus, practically speaking. You can even have one entity go offline and take down a huge chunk of the hashing power for, you know, a public network. That's not going to happen with us, right? We are more decentralized in consensus in those ways than a bunch of the public networks today, and we continue to decentralize along that path. So I think that we are highly decentralized along both dimensions. It's by design. It's not always intuitive when people initially view what we have, but in reality, I think it's the case.
Thank you, Mance. I'm sure that won't be the last time that we get that question, but you know, we will continue to share that message with the market. And I think it's important that it's not a simple one-liner. There's been a lot of thought and there's a lot that goes into that.
Right.
Okay, we are at almost the very top of the hour, but
Oh,
Leemon,
good.
we got so many questions about the Turbo Encabulation Algorithm. Can you share a little bit more there, please?
Yes, Turbo Encabulation Algorithm. It's easy for you to say. This is a great joke. It goes back 70 years. So in the 40s or 50s, 40s, I think, someone published this article on a fake machine described entirely with made up words. And it's just funny. And then people later made videos out of it. Time magazine published a Turbo Encabulator article, and it was hilarious. And people even wrote letters to them saying, I like your article, but I'm not sure I understood it completely. Could you explain it a little bit better? You know, it's all made up words. It's just a joke. And so there's a whole bunch on YouTube of Turbo Encabulator videos. There's a Wikipedia article on Turbo Encabulators. And I just thought it'd be fun to make our own joke video. So I made a Turbo Encabulator video. It's 1.5 minutes long, and it's just me babbling made up words. But it was fun to make. I hope you enjoy it too.
Thank you, Leemon. Leemon, Mance, thank you so much. Community, thank you for all that you do and continue to do. We so appreciate you, and we look forward to chatting again next month.
All right. Thank you. Sounds good. Have a good month, everyone.
Yep. Thank you.